Michelle, in California, what's going on in California in terms of decarbonization regulations? Like, are they saying no gas for your water heaters, or you can't use gas heat in commercial air conditioning, or is there anything like that happening?
Yeah, so we are electrifying California. So for new construction, you're not supposed to be using gas. But yeah, that's the main thing is electrification. And there is a really big pushback because we don't have the infrastructure. No one's denying that we don't have the infrastructure, but it's allowing for bigger entities to kind of reevaluate their infrastructure, and they're looking at doing microgrids. They're looking at having more renewable energy. Solar is obviously super popular in California. So that's kind of what's going on here.
Okay, welcome to the Engineers HVAC Podcast, where our mission is to empower and educate the HVAC community. This podcast is brought to you by Insight Partners and Hobbs and Associates, two commercial HVAC rep firms. I'm your host, Tony Mormino with Insight Partners, and today we'll be discussing decarbonization, the future of net zero buildings, and some other topical issues. And today I have two special guests all the way from California on the West Coast. So we'll go ahead and do a little introduction. Michelle and David. Michelle, why don't you go first and tell the listeners a little bit about yourself?
Tony, it is so great to meet you. Thank you for having us on the podcast. I am Michelle Shadpour. I am a project engineer, project manager out here in San Diego, designing mechanical and plumbing facilities or systems for healthcare facilities and pharmaceutical and federal buildings.
Oh, wow. Okay, good. That'll give us a lot to talk about for sure. Pharmaceuticals, hospitals, and federal buildings, all three very challenging applications to deal with, or clients to deal with, I'm sure. But anyway, so cool. Michelle, thank you for joining us. And David, why don't you give us a little rundown of who you are and what you do?
Tony, first of all, thank you. Big fan of the show. So excited to be here. And I actually work with Michelle at Shadpour Consulting Engineers based out of San Diego. And I have been a nerd my entire life. Went to USC, fight on Trojans, for mechanical engineering, but do a lot of electrical design too. So I'm licensed in both mechanical and electrical, as well as plumbing. And my passion is trying to design and create more sustainable buildings and do so through smart design. And so I'm so excited to share these ideas, and I look forward to continuing to do great things in this industry.
Awesome. Well, I'm glad you both are here, and I'm looking forward to the conversation. And I don't know if we've had anybody on from California before. You know, most of our listeners are probably I'm in North Carolina, and Michelle, you're down in San Diego, and David, you're up in Portland today, right? So we've got like this national triangle thing going on covering the country here. So we can hit all the angles, but no, I'm glad you're here. So, let's just get right into it. So decarbonization, right? And you guys tell me who wants to take this one, but what is decarb for the person who's not familiar with what it is?
Yeah. So decarbonization is the idea of reducing the amount of carbon emissions we release into the world. Carbon is the source, or is one of the sources for global warming. So as we produce more carbon emissions and carbon dioxide emissions, it goes into the atmosphere, causes global warming. In some cases, or up until recently, it's actually been a benefit for society because it's kept our Earth a temperature that humans can evolve in. But we're finding that over the past 100 years, it's been exponential how much that we've been putting out.
Right.
So we of reducing that.
Gotcha. Yeah. So we burn fossil fuels. Stuff goes in the atmosphere from burning the fossil fuels. The stuff stays around longer than we want it to. There's more of it in there. The energy from the sun heats up the earth, but it doesn't get a chance to escape as much if there's more stuff in the atmosphere, basically, right?
Exactly.
How'd I do on that, David? Is that accurate?
Tony, I couldn't have said it better myself. Essentially, the way I see it is there's kind of a blanket around the earth, and the carbon may make that blanket too thick for what naturally should be occurring, and that will perpetuate on itself, because then our polar caps and the ice will melt and less sunlight will actually be reflected and the earth will warm up more and then there'll be more carbon released. So it can be an issue. And the way I think about it, that really kind of scares me if we don't handle this potential issue correctly, is it took hundreds of millions of years of plants, dinosaurs, animals to create all these fossil fuels under our planet. Hundreds of millions of years on the inside of our Earth's crust. It took hundreds of millions of years. And now in just a couple hundred years, we're trying to release all that after it built up hundreds of millions of years. That's not natural. So there's a lot of data out there, a lot of studies, but the way I look at it is why take the risk? Humans are taking the biggest risk by releasing all of this carbon into the atmosphere, and it is a risk, so why do it?
Got it. So let's move into the kind of like what's going on to prevent this in our industry, HVAC industry. Okay. So since you both are in California, I'd love to hear your take on what's going on in California. And it's funny, when you go around the country, we have offices in New York and they have a different feeling about it than our offices in Georgia have a feeling about it, right? So it's like very unique in terms of where you are in the country, in terms of if that's something you even is on the forefront of your mind. So Michelle, in California, what's going on in California in terms of decarbonization regulations? Like, are they saying no gas for your water heaters, or you can't use gas heat in commercial air conditioning, or is there anything like that happening?
Yeah. So we are electrifying California. So for new construction, you're not supposed to be using gas. There are different cities and parts of the state that you can continue to. But yeah, that's the main thing, is electrification. And there is a really big pushback because we don't have the infrastructure. No one's denying that we don't have the infrastructure, but it's allowing for bigger entities to kind of reevaluate their infrastructure, and they're looking at doing microgrids. They're looking at having more renewable energy. Solar is obviously super popular in California. So that's kind of what's going on here.
Right. And when you say infrastructure, David, explain to the audience. I think what Michelle's saying is, like, instead of putting a gas boiler in, you're now going to use electricity, electric heat pump, water heater, something that takes electric power. We may not have that much on the grid, right?
Right. Our grids, it's pretty crazy when you really think about what the electrical grid is. And I think before the internet or some of these newer technologies, I thought it was the most amazing thing. The US has essentially 3 main grids. Texas has their own, and then there's 2 other ones. But it's crazy. All the way to the point of the outlet where you charge your iPhone at night to the power generation, everything is interconnected. It's like the craziest spider web you could ever imagine. So that's happening above ground, underground, and this grid was made for a certain amount of power that has been increasing progressively over the years and the decades. However, if we move everything to fossil fuels too fast, this crazy spider web or this crazy grid may create this jolt of demand, and the infrastructure isn't there to provide that supply. And so that is definitely a concern where we have to understand where there is some opportunity to make the grid be able to handle this potential jolt in demand with EVs and moving to all these electrical sources instead of fossil fuels.
Yep. And that's one of the things we hear a lot here is, like, what about the grid? And then the other thing, Michelle, is a lot of our plants are coal burning. So we're taking the, gas boiler out. We're putting electricity into the building to heat the water, but then we're putting the carbon back in the atmosphere at the plant anyway. Now, I know I think the overall goal, and you tell me, is to make it so it's all renewable or sustainable, right? But in the interim, we are transferring CO2 from burning it at the building to the plant. What do you say about that?
Yes, that's right. I remember when like electric vehicles first started becoming popular, I was like, it's not better for the global environment, sure, maybe your local environment. But yes, the goal is for it to all be sourced from renewable energy. And what we're seeing in California is there have been proposed new power plants, but they've decided to take that money that would have been allocated to building that power plant and
Mhm.
providing it as incentives for people to do retrofits, energy efficiency retrofits in their buildings.
Are a lot of the buildings you're working on, I would assume maybe some of the federal ones going with like solar panels, and do they do wind on site? I don't know if that even happens, but are they using any type of renewals in their design currently?
Yes, definitely.
Mhm.
For all of our federal projects, we're exceeding 30% energy savings compared to a comparable building. And sometimes that does include having to provide renewable energy.
Mhm.
Some
Yeah.
places that I've found that difficult is our projects like in Alaska or comparable climates because they
Mhm.
don't have the as big of a benefit from solar power as we do down here closer to the equator. So things like solar and other renewable energy are more popular in those parts.
Yeah, and they need a little more heat than you do in San Diego, I'm assuming.
Yes, I think that's a safe assumption.
I think Alaska, you can stick with the gas for now. We'll take the credits here. You can stick with the gas for a while when it's negative, whatever it is. But
Mhm.
yeah, and that reminds me too. That I was on somebody's show. I don't know a few days ago. We were talking about heat pumps in cold climates, and I'm sure you're seeing a lot of heat pumps in lieu of gas heat. Like we're in North Carolina here, so it's relatively mild. We'll have some single digit temperatures every once in a while, but the heat pump in my home could heat the home 24 set all year round here. It doesn't matter. Like so, and I think there's a misconception in colder climates that heat pumps don't work. So do you all ever run into that in your areas? Are heat pumps popular for air source equipment in your area?
Yeah, heat pumps are very popular because you're getting such a good coefficient of performance, or in
Hmm.
other words, the amount of power you input is low relative to the amount of heat you get, which is a
Right.
good thing. And one thing we've noticed and done on very, very cold climates where heat pumps may not work, because if you think about a heat pump, it's just rejecting cold into the cold outside so that the resulting heat stays in the building. That's all it's doing. And I know
Hmm.
heat is what's really moving, but that's all that's happening.
Right.
So when it gets too cold outside, the heat pump doesn't really work because you could imagine if it's 0 degrees outside and you want to reject cold, it's going to be really hard to push even colder into 0 degrees outside. But
Hmm.
we've come up with some hybrid strategies, either with a little bit of gas or using electric resistance heating so that you still get that 1-to-1 coefficient of performance at very cold conditions. But 90% of the year, when it's relatively mild outside and you still want heat, the heat pump will give you a lot of bang for the buck. So that's what we've seen.
Got it. Yeah, we see a lot of that here too. And just if you're listening, the COP is an important thing for heat pumps. It's generally three, if not more, and the COP of electric heat is one. So you get at least three times the energy out of it. So the higher the COP, the better is how that works. The same with SEER
Right.
ratings. Cool. Yeah, so I'm glad to see heat pumps are working there too. But so Michelle, let's talk about some challenges. Like, what is the biggest challenge and opportunities for HVAC engineers? I got two HVAC engineers on here. Like, what's the biggest challenge when it comes to contributing to decarbonization efforts and education? And I know both of you, I've seen you both online, so you could talk a little bit about that too if you want, like what you do online to help.
Oh, yeah. Well, I guess we'll start with the online part and education. Both David and I feel very strongly about just educating people and not just people who are interested in becoming mechanical engineers and participating in the built environment, but educating everyone in general, like that our facilities are such a big component of energy consumption and carbon emissions around the world. So what I've been doing online is just posting short 2-minute videos on just like specific topics just to educate people. And I'll let David speak to, he's a professor at a local university, and then he also has done a couple TED Talks.
Nice. Yeah. I want to hear about David. I did watch his TED Talk. So I'm curious, Michelle, because we don't see a lot of we have this conversation all the time, in commercial HVAC. There's not a lot of folks online doing, education and getting out there on social media. What inspired you to turn on your camera and and by the way, if you don't, I'll put your information in the show notes. So if someone wants to go check it out, Michelle does these great 2-minute videos, 2 or 3 minutes. I don't know, you correct me, on specific topics. So what encouraged you, or what got you motivated to do that?
So I have been wanting to do it for a while, and it was crazy to me that I've had so many people in my life and they didn't really understand what I did. Like, they knew I went to school for mechanical engineering. They knew I was involved in the built environment, but then they were just like, they didn't get it. And even I explained it so many times, and it's such a fundamental like aspect of a building that I wanted to just I felt it was important for people to understand what we do in the built environment. So that's how I got started there.
What would you say to a mechanical engineer, someone in HVAC engineering, HVAC design, who wants to give back online? Like, was there a fear you had to overcome? How did you overcome that? And is it easier, and has it been a fun experience for you? Any advice to someone who might want to do that?
It's been so fun. I've received so much great feedback. So many people have told me they wish they saw videos like this when they were in college. I would recommend for people to just go for it and do it. It is fun. And the one thing that I was concerned with, and I voiced it to David, and David said, just go for it, do it, was I am very serious at work. I take work super seriously. I'm really proud of the stuff I do. And I was concerned that people would see my videos and think that it's like silly, or just discredit me. But it's been funny now doing it. I do see other people posting videos, and that's how I found you, Tony. And it's just interesting that once I entered that realm, that's when I found that there were others.
Isn't that crazy? I mean, you both are here because of you turning on your camera and doing that, right? Like, we engaged on LinkedIn, and so it's really cool. It's awesome. And I'm glad you're doing it. I appreciate it. And it would encourage more mechanical engineers or more HVAC design folks out there to do it, because it is a great way to give back, and it is a great way to grow, professionally. And, for me, like, I was terrified to do this stuff in the beginning. If you go back and watch my other videos, it looks like I was going to faint, but it does get easier, and it's a great way to give back. David, what about I saw you, David's a famous YouTube TED Talk talker. So talk a little bit about that.
So one thing that I want to mention is a question you had earlier about the challenges, because I see that as very important. Do you mind if I talk about the challenges of this?
No, go for
decarbonization? Because Tony, this is I see decarbonization as one of the biggest issues with society in the future. And one challenge that I actually see that I think we need to overcome with podcasts like this and talking about it is the traditional media. It polarizes decarbonization. It's turned into a political debate, but it shouldn't be at all. Decarbonization is a good thing, and we can all agree that we don't want to take this risk of spewing endless carbon into the atmosphere. We want to be sustainable and treat our planet well. That's not a debate. That's not political. The problem is a lot of decarbonization effort in sustainable technologies, I found they're not as good right now. But that doesn't have to always be the case. So like Tesla is a really good example. And I personally love Tesla. I know the media tries to hate on Elon Musk. But if you've ever driven like a Tesla car, it's very, very, very fast, and it's very luxury. And it's also good for the environment. And I think that makes it not debatable. Everybody's going to agree, hey, this is a cool car and it's good for the environment. The issue is if you're driving a very slow, car that's electric, you have to say, well, it's good for the environment, but it doesn't work that well. And that's where it becomes political and kind of a debate. So I want our challenge to overcome this dichotomy and this argument between sides. I want us to realize decarbonization is good. It's just a matter of designing and creating products that are also the best and good for the environment. So it's a win-win.
100%. I'm glad you said that, because it is, sometimes, we're in the Southeast, so sometimes it's a little like, got to be a little careful, because it is taken differently in different places of the world. But I have found that within the engineering community, I mean, engineers are so different in this most of the time. Like, we're like, okay, yeah, if we're going to stop the carbon here and move it here, that doesn't make sense in the long term, but it's a first step in getting renewables. And I think no one's going to argue that, yeah, at some point we're going to run out of, fuel at some point on the earth, I would guess. And it's good to have renewables and sustainables. It's just, how do we get there? And let's all relax and not hate on each other. It's that's the part of it that gets and I wish, like, these initiatives, and it's kind of the same with the refrigerant phase outs, right? We have to react to them in the HVAC business. We don't really get a say in them. Like, there's not a lot of engineers making these decisions long term, in my opinion, that should be more involved. But anyway, so I'm glad you brought that up. So talk about how did you get on the TED Talk? Talk about that for a minute.
Yeah, so with the TED Talk, as you could probably tell, I'm a pretty big nerd. So it was probably a weekend.
I was just writing that down. What a nerd this guy. No, I'm just kidding.
Yeah. I was probably going to bed on a weekend at 8 p.m. and thinking in my head some different ideas and writing in my journal that I like to write in before I go to sleep. And I had all these ideas about sustainability and really why it can be a win-win, whether it's net zero, decarbonization, electrification, how it can be a win-win. Yet the media and what you see online and talking to people, it's not win-win ideas I see out there. So I had a win-win idea, and I've given 2 TED Talks on them, and I have one more planned upcoming. And I just saw TED as the best way and platform to spread these ideas. And I get nothing from the TED Talks too. So it's all altruistic and magnanimous to share these good ideas with the world. I get nothing from it. And essentially, I just reached out to a event and I said, hey, I got an idea. They do a few rounds of interviews. They see if you're a good public speaker, which I had no training on before I did the first one.
Was that your first, the one that I saw, was it your first one? Is there only one on YouTube, or is there multiple?
There's 2 on YouTube. The first one was on net zero energy, and the second one is on decarbonization.
People have no idea how hard public speaking is, I don't think.
Yeah, I saw somewhere that it's the most fearful thing. I said, what about death?
Right.
Nope, people are more scared of public speaking. But I just want to spread good ideas, and I just want to make this planet a better place through these good ideas. And TED is a great platform to do that.
Yeah, I do a lot of public speaking, and I think I'd be terrified if I got invited on that, because it's such a big platform. So good for you for going to do that. That's awesome.
I'd absolutely watch yours. I'd be in the front row when you do yours.
Oh my gosh, you guys are, yeah. Well, good. I'm glad. Okay, so let's see here. Anything else on decarb? I want to talk about, we can move on to the net zero energy buildings. Anything more on decarb? Any last words?
We could go on and on, but we can move to.
I could go on and on all day.
Yeah.
Your computer's going to run out of battery, but basically.
That's like when I'm on a show and someone asks me about doing social media marketing. I'm like, where's your timer? Don't even get me started on that. Like, because I just, anyway, so.
Yeah, but there is one thing I do want to mention, and it's not technical at all. It's something that I've noticed in this industry. It moves very, very slow. Like the architecture, engineering, construction industry, we don't like change. And Michelle is actually really good at this. So she's a great colleague to work with on stuff because she thinks outside the box. But what I've noticed, and a good example is this, I don't even know if it actually happened, but it's a famous study they did, and they put fleas in a jar. And, fleas, they like to jump. So they're all jumping, trying to get out of this jar that has a lid on it, and they're hitting the lid, and they just kept the jar on. Eventually, they took the jar lid off, and the fleas were so conditioned to not jumping because they'd keep hitting the top that they didn't even jump out of the jar when the lid was taken off.
Wow.
So we don't even know why we do what we do in a lot of cases. We've just we just do it because, well, that's how my mentor taught me, or that's how the previous generation taught me, or that's how we've always done it. So I feel like with decarbonization, we can do it. We just have to think outside the box and not just say, well, I'm just going to do it this way because that's the way I was taught and that's how I'm always going to do it. Just like the fleas that don't know why they're not jumping, but they're just conditioned to it.
Yeah, change is hard. That's for sure. I think it's hard because it's scary. And, when you get older, you're just like, man, I'm just tired. I just want to go home.
Yeah.
Get
Have
on
you
the
noticed
couch and
that
deal
too,
with this
Tony?
stuff.
In
Yeah.
North Carolina, is that kind of the same culture where you see like this industry moves a little bit slower than it could? Like there's so much opportunity, but old facilities teams and old contractors, old designers, they do things in same way they've always done it. Have you noticed that too in
Yeah,
North Carolina?
I think that's true in most industries. It's just like, we as humans in general, we just get into our groove and we get in being out of our comfort zone is not fun for anybody. And I don't care what
Right.
industry you're in. That's what I've learned over time. And people don't want to, it takes risk to design things in a different way. And it takes, ingenuity for the manufacturers to come up with new products. And I do feel though, like in our industry, from a manufacturing equipment standpoint, they do a great job of keeping up with efficiencies and trying to invent new things because it's good for business, right? It's good to have that 0-degree heat pump that is efficient and things like that. So,
Right.
um, yeah, cool. Okay, let's move on to net zero energy. I really like this topic. This is exciting to me. So, Michelle, the path to net zero. So, what are the key strategies for designing a building to achieve? Well, what is net zero? First of all, what is a net zero building, and then how do we get there? Talk a little bit about that.
Sure. Yeah. A net zero energy building is a building that produces as much energy as it consumes over the course of a year. So, any
Okay.
given day, you could be consuming more energy than you're producing, maybe because it's a cloudy day and your solar isn't producing enough energy. But then throughout the year, you're going to be making up for that.
And it's a net,
Um,
correct? Oh, go ahead. Please finish. Go ahead.
No, yeah, I was just gonna go on to the second part of your question, which is like, what are the key steps? There are so many players in a net zero energy facility. You have the architect who's making sure that you're providing adequate insulation on the walls and the right types of
Mhm.
windows. You have your mechanical engineer making sure you're selecting the right type of system. You have controls, which I would argue is the biggest component.
Mm.
And then you also have the occupant, which has a lot of power and say in how the building performs.
Yeah, so that's good information. So a net zero building, I got some friends here who live off the grid, right? They they have cabins in the woods.
Amazing.
They have if they have a stream, they have a little water thing. They have solar panels. They might have a wind turbine or something like that. It's hard to do that. Like like I don't want nothing to do with that personally. I'm all for being green and energy efficient and stuff like that. But they're not hooked up to the grid at all. The point I'm trying to make, like a net zero building is hooked up to the grid and it's giving power when
Yes.
it has excess and it's taking when it doesn't, right? Is that typically how it
It-
works or
yes, it's typically how it works, but that's not always the case. You could have
gotcha.
battery storage. Yeah, there's other alternatives.
So you could have batteries, but they typically a commercial building is not tethered from the grid. Is that correct?
Correct.
Okay,
No,
gotcha.
typically they are connected to the grid. Yeah.
They are connected to the grid, right, right, and it's just
Yes.
like when they're producing more energy than they're using, they feed that back to the grid so that over the year's time, you're saying it's a net zero because yeah, gotcha. Yeah, have either of you been to
Mhm.
the AHR ASHRAE headquarters in Atlanta?
No.
No, but I've watched many presentations on it.
Yeah, they've got a lot of, they're trying to be net zero, they're getting close, they have some renewable energy stuff there, but the controls are a big part of that too, like you were saying, so, um okay, so David, in a net zero building, like technology and design synergy, this question's titled. So, how do you see the role of HVAC engineers evolving as buildings move closer to net zero energy goals?
Yeah, so Michelle mentioned there's a lot of parties involved when it comes to net zero,
Hmm.
and that's absolutely the case because it is a challenge right now for a building to use up less than it brings in or generates itself in terms of power. That is tough.
Mm-hmm.
So there's a lot of synergies, but the way I look at HVAC specifically, and really all the different parties, but you have to focus on HVAC a lot because most of a building's power is due to HVAC equipment. Lighting is so efficient now that it's a small fraction of what it used to be 20, 30 years ago in terms of how much power a building uses. So I think what an HVAC engineer or team needs to do, they need to just brainstorm. Like we all learned in high school, before you start writing the essay, let's take 5 minutes and
Mm-hmm.
just brainstorm before we start writing. That's what you need to do here, because the old school way of designing an HVAC system or a building was just design it. And whatever power you need, I'm just going to take this big plug and plug it into the grid. Who cares how much it is? Nobody cares. You're just plugging it into the grid.
Mm-hmm.
That's the old school way. The new school way, the HVAC engineer needs to sit down with the team and say, hey, here's how much power our equipment is going to take. Can we generate that on site? So you don't just have a bank account that you just keep spending money during design and just plug it in and say, hey, I'll pay it back later. No, you say, hey, here's my budget for how much power the HVAC equipment will use. Can we generate that amount of income or power in this case so that we don't go into the red, we don't go negative, and it's actually feasible? So that brainstorming step to make sure your building can generate as much power, whether it's with solar panels or something else, that your planned equipment can consume, that's the most important thing that people generally skip. And you need to do that to make this a feasible achievement.
Mm-hmm. Is there typically, like, in the process when you're in the design phase or the preliminary phase, is there a typical point where you say, here's 3 options for you, Mr. Owner, and this one has a 20-year payback, this one has a 5-year payback, and this one has a, do you know what I mean? Is that typically how this happens? And then they get to make the decision, okay, we want to do decision C because we're more focused on green. We don't care if it's a 20-year payback. Either one of you can answer that one. If you have
Yeah.
experience with that.
So, yeah, generally you give 3 options to a client so that they can choose. That's just kind of standard. But at the
Mm-hmm.
end of the day, we're the experts. The owner may not understand how this stuff works. So they're paying us not for our time. A lot of people with billable hours, they think they're getting paid for their time. That's wrong. You're getting paid for your value and expertise. So while we do present options often, they're relying on us for the best value system. But to your point, Tony, this is something that gets missed a lot. People always assume that price is all that matters. So they'll do life cycle cost analysis, or they'll only look at payback period in terms of price. I think another very important thing that people don't do, and they should understand the owner's goals, whether it's for the project requirements or just their goals. Because an owner may be part of a big corporation that has 20, 30 net zero goals. And so costs may not be the biggest deal, but reporting to their CEO, hey, I'm going to achieve this benchmark you promised to all of our shareholders, that may be what they're looking for. So in a weird way, the most important thing is understanding what your owner goals are. And if it is payback or initial cost, that's when you can design. But the first step is to understand the goals of the project, because some owners may say, hey, we promised our shareholders of this big corporation that we're all going to be net zero. So pay as much initial cost. We don't care about payback period. Just make it work. So understanding the goals is just so critical.
So upfront conversations, right? Don't go in there with the green net zero building if they don't care about that, because it is an investment, right? There has to be, it does exceed the cost of a standard design. So if that's not important to them, right? So you got to have that conversation up front.
Upfront conversations is as important as ever. It's always been important to brainstorm and be upfront, but now with this transition period we're in to decarbonization and net zero type buildings, it's even more important than ever.
Got it. Good. So do either of you have any case studies you're familiar with for net zero buildings you want to discuss?
I have a project right now where I'm doing providing 3 alternative options, and
Mm-hmm.
it's not for a net zero energy building, but the owner initially came to us and they said, "Hey, we have this steam boiler plant. We're serving a 24/7 major medical center. We need to replace the steam boiler." And
Mm-hmm.
that's what they wanted. I could have given them the design they asked for, provided a temp system, in-kind replacement. I talked to them before pursuing the design and I said, this is a major opportunity to decarbonize your facility. And so what we ended up doing is we put together 3 options. The first option is what they had asked for.
Mm-hmm.
In-kind replacement, we're replacing with gas-fired boilers, and they're dual fuel for emergency cases. And then the second option, I said, hey, let's take off all of your heating hot water system from the steam boiler. Let's take off all of your domestic hot water system from your steam boiler. They're going to see massive savings because steam boilers, they're great, reliable systems, but they do have a major waste and it all goes like quite literally down the drain.
Mm-hmm.
And then in addition to that, I provided the third option, which was decentralized steam entirely. And for equipment that does need steam, such as humidifiers or some kitchen equipment, just provide some local pieces of equipment. And with that, they no longer require having to have a 24/7 boiler attendant. So right off the bat, they're saving someone's salary, 2 people's salary with that. So it's those activities are really fun when the owner says, hey, this is what I want. And then you give them some options that just enhance their facility just all around.
Yeah, so that's something that may happen just because you brought it up. If you wouldn't have brought it up, it would just been a like for like replacement, right?
Exactly. And it also just gives the facility more flexibility in the future for their plans. If they end up doing a microgrid and end up providing solar power, the new equipment that we're providing, it could be electric. So just there's more
Nice.
flexibility here.
Yeah, if you're going to upgrade it anyway, here's a good chance to, you know, do something a little different, move down the road on this deal here. So awesome. Okay. So no podcast would be complete if we didn't talk about AI. So every podcast we do, this comes up. So I just want to, do you see any, like Michelle, you talked about the importance of controls earlier, right? And I had a guest on yesterday who is what I consider an AI expert. He's developing all these tools. You might be interested in this, to like, you could take a submittal and you could take plans and specs and upload them to his program, and it will give you a shootout of what is matched and what is not matched. So I think that's a pretty neat tool. But in terms of like building controls and automation, are you seeing how AI might play a role in any of this?
I can answer that.
Oh, yeah.
Or well, I just want to chime in on because I was actually just thinking about this myself when when other people are thinking about what's the new Netflix show out or who won the Super Bowl. I think about this stuff. So
Hmm.
this is the question I'm most excited for. So I had to steal Michelle's thunder on this one. I'm sorry, but
We'll get you in there, Michelle. Don't worry.
but so the one thing that I see is AI or tech in general. This isn't like specific to some industries. This is going to touch us all.
Mm-hmm.
And so, in terms of energy, buildings are the biggest users of energy on our planet. It doesn't get the love as cars or planes or even Bitcoin mining. Buildings use almost half of our world's energy. And a big part of that is from mismanagement of the systems,
Mm-hmm.
whether it's lighting or HVAC. Right now, they're all controlled by this brain at the center of a building called the building automation system. And I see so many things wrong with this brain. Essentially, you have some guy program it, the control system for a building, and then he leaves the company or he messed up on it or he wasn't experienced running incorrectly where you're air conditioning at the wrong time, you're heating at the wrong time, your lights are on at the wrong time. All this stuff is just inefficient from human error.
Mhm.
Waste, just a lot of waste. AI can come into our buildings and make those decisions for us. AI can look at, hey, here's the weather for the next week. How does it make sense to run our HVAC system? Hey, here's when the sun is setting due to the time of year, daylight savings. How does it make sense to dim our lights as the day progresses? AI is going to take this brain that controls our building and make it exponentially more efficient, which is going to radicalize our entire industry, and it's going to save so much energy. So I'm very excited what AI can do to our brain or our building automation system in all of our buildings around the world.
I like it.
Sorry for
Michelle, what are
taking your
your
thunder, Michelle. I know your answer is going to be exactly the same as that one, word for word, verbatim, no differences.
It was. I was gonna say that. So the way that we're seeing it emerge right now, and what everyone's talking about, is exactly what David said, and it's called connected commissioning, or automated commissioning, depending who you talk to. So currently, the way retro commissioning works is a building's operating. They hire us to come in and evaluate, analyze the trend data, determine, hey, what is going on and what's not operating as intended. So that we get paid a certain amount of money and we come in maybe like after the building's been operating for 10 years. What AI can do for us is allow that process to be continuous, and just if something is tweaked, it automatically tweaks it back. And that's going to be retro commissioning in particular saves about 30% in energy savings, which is
wow.
insane. To imagine that we wait 10 years to go in and do that process, AI is going to allow us to do it continuously.
I love it. And I had an expert on the show a couple of months ago who's well involved in this, and he works for one of our manufacturers, and he's like, look, we need to, the equipment's almost there. Like, we can't squeeze a lot more juice out of this, out of what we're doing, because to get like an example of like the air cooled chillers have kind of plateaued in their efficiency. To get another 5% of efficiency out of them, you got to throw 30% more metal at it. It's just not practical. Like, we've almost reached the limits of, I'm sure every decade we say this and then something else comes out, some new advance, but like, we have to look at the building as a whole, right? We have to look at the building envelope. We have to look at the controls. The training of the operators is so super important. I think it was David who said this, a guy's there, he knows the system, he knows how it works. He leaves, someone else comes in, he has no idea what this thing does. I'll just turn that off. Or why is this damper open? We got all this outside air coming in here, and he shuts the damper off. And, so it's like, it's like a whole building thing. It's not just the package rooftop unit. It's not just the chiller. It's not just the tower. There's just so much involved in that. Okay, so that was good stuff. So, next generation of building architects and engineers. Michelle? What's your advice to someone who's new, that maybe might even be in college? We got people in college listening to this that are coming up. What do they need? What kind of skills do they need to know to be ahead of the curve when they come out? Any advice on that?
Well, David and I always joke about it. We say, "Do you know Revit?" So, understanding Revit is very important.
Yeah.
But I think also making an active effort in trying to understand the system as a whole.
Mhm.
There's this story that I tell in most of my presentations about the blind man and the elephant. And it's about these blind men. They're asked to go touch an elephant and describe what an elephant looks like or is similar to. And so the man that goes up to the trunk says, like, oh, an elephant's like a snake. Or yeah, like a snake. And then the man who goes up to the elephant's leg says, like, oh, it's like a tree trunk. And while the understanding of those pieces of the body are correct, they don't have the whole picture.
Mhm.
So my biggest recommendation to young engineers, construction professionals, architects is go experience a lot of the industry, because wherever you end up, it's going to just make you so much better for it. So that's my biggest recommendation.
Great advice. Well-rounded system knowledge, building knowledge, et cetera. That's great. David, what would you say?
So we love our stories. So when you were, whether it's elephants or fleas or any story, us Shadpours love our stories. So
Yeah.
one thing that I tell everybody that comes to me is this story about Wayne Gretzky that Steve Jobs made famous. I don't even know if Wayne Gretzky actually said this, but apparently this
Yeah.
average height, scrawny guy, Wayne Gretzky, has all the records. He's by far the best hockey player of all time, but he's just an average guy. And they said, Wayne, how are you so good? You don't even look that athletic. You're not even that big. Why are you so good at hockey? Why are you considered the best player of all time? And Wayne Gretzky said, well, all of my teammates, everybody I knew within the league, they always skated to where the puck is. But me, I always skated to where the puck was going. So people in today's school system, it's not their fault, but the curriculum is teaching the wrong things. Michelle is totally right about Revit as one example, but that's what somebody new into the industry needs to focus on. They need to focus on design being more than just a drawing on a paper or a 2D print. You hear it with like Facebook or Meta, this metaverse. This is real. It sounds crazy, but it's going to impact every industry, especially ours. And you see the Apple Vision Pro headsets and the Meta headset. That's going to impact our industry really quickly. So our designs are not going to be 2D. They're not even going to be 3D. They're going to be more dimensions, taking into account time. They're going to be part of scheduling and phasing. So these new engineers, they need to start by really, really, really learning BIM, building information modeling, whether that's Revit or another program. If you can do that, you're going to be able to design the buildings of the future, not only on the initial design, but also the contractors building it. They're going to be looking at BIM shop drawings. The facilities team, they're not going to be looking at PDFs anymore or prints. They're going to be looking at digital twins, which are going to be these same metaverse type facilities to keep it going. So you need to learn BIM as a young engineer. I don't know if they teach it at school or not, but you should be watching YouTube, listening to podcasts, practicing on your computer. You need to learn building information modeling, and Revit's the main program we use in this industry.
Excellent. Very good advice from two experienced HVAC professionals here. So anything you want to promote, anything, your TED Talk, your website, a book you got coming out, anything you want to tell the viewers to get connected with you on LinkedIn, or David, you go first.
So Michelle and I at Shadpour Consulting Engineers, we're open to new projects. We love expanding our horizon. We're pretty busy right now. A lot of late nights for me and Michelle, so don't go too crazy with all the requests. But yeah, we work together, so there's that. But more importantly, our goal, the reason Michelle and I got into this industry is no other reason than we want to change the world for the better. And we saw the ability to do that through design of efficient systems and sustainable systems. That's how we feel like we can impact the world. And so the TED Talks are probably the best example. So you can YouTube David Shad or David Shadpour TED Talks, and they'll come up. And I get nothing from it, but I ask you to really share that with your network, because this isn't a local problem trying to be more sustainable. We all share one planet. We all share one globe. It does nothing good for if North Carolina or California is super sustainable, but then you have other countries trashing our planet. So it's a long answer, but if you share the messages in my TED Talks, that is something that I think we can really, really, really get a network effect there and really show the world the right way to be sustainable.
Excellent. And if someone Googles Shadpour Engineers, or it's an SC Consulting, either one of those?
Yeah, I like to talk too much, Tony. It's a one-word answer. I should have given to that. But yeah, Shadpour, Shadpour Consulting Engineers, or SC Engineers. If you just Google it, it'll come up. We're based out of San Diego. And then my TED Talks, just David Shad or David Shadpour TED Talks, they'll also come up. And yeah, those are the two things that I want to focus on, because I'd be talking to you all day, Tony, here. I like the sound of my own voice, apparently. I just learned that today.
Well, we'll have you back on the show. So, Michelle, what about you? Anything you want to...
Be careful what you wish for.
That's right. That's right. Anything you want to talk about? People connect with you? Or?
Yeah, connect with me on LinkedIn. I post videos. I would love to get your guys' feedback or any ideas on things you would like for me to share. And then most importantly, even without the feedback, just watching the videos, I think everyone should learn something new every day, and this is an opportunity to learn something.
Excellent. Well, thank you both so much. And thank you all for listening. We will put David and Michelle's information in the show notes. Whether you're watching this on YouTube or listening to this on your favorite podcast platform, you can connect with either of them and check out their consulting firm over in San Diego. And thanks for listening. Don't forget to go check out our YouTube channel at HVAC-TV. And David, thank you so much for coming on.
Thanks, Tony. Really appreciate it. Blessed to be here.
Thank you. And Michelle, thank you for coming on. We appreciate you.
Big thank you, Tony.